Hello everyone, my name is Vinay Patil and today I am going to tell about the expression for drift velocity. So we have to derive the expression for drift velocity and that is very important derivation for board and also competitive. Okay, that is from the chapter current electricity. Okay, let us solve that now. That is very easy derivation, you can solve it easily and you can remember it and then you can do it very easily in the examinations. Okay, let us do that. To derive the equation, first we have to write a diagram. Okay, let us write the diagram is very simple, you don't have to worry about it. First make a circuit like this. First make like this. I will write the big diagram. Okay, after doing this, here this is plus charges will be there, here will be minus charges. Okay, after that here electric field are surrounding, they are revolving around this, inside this, that is drift velocity, and electrons also will be there. Okay, I will write like this. After that this is consider A, this is B. Okay, simplify, we are writing A and B, you have to consider them. After that make like this, here we make the EMF. After that, okay, this much is the diagram. Here this is plus q, means source charge it is, minus q it is, and here is p from here to here, full length it is. Okay, after that what you have to do, you have to write the consideration. This was the diagram and very easy diagram. Okay, you can remember it very easily, that is very simple. And after that consideration also very easy. After watching this diagram, you have to write the consideration. Let us write that now. Consideration, what we have considered here, we have taken a conductor here, so again on that conductor we have to write the consideration first. So let us write that. Consider a conductor, consider a conductor having large number of randomly moving charges. The charges are randomly moving inside this conductor, so we have to write that in the sentence. That is very simple. Consider a conductor having large number of randomly moving free electrons. So after writing this, what we have to write, and the average velocity will be 0 inside the conductor. Okay, write that one. Their average velocity will be 0. Okay, this much you have to write. After that you see the diagram, and after that write one more consideration. Okay, that is also very easy, so let us write that now. When the moving free electrons, or you can write it as when drift velocity, you can write when conductor, in drift velocity we have the conductor, in conductor that drift velocity is there and electrons are revolving around this conductor, in this conductor. So let us write that when conductor is placed in the write that now directly. When conductor is placed in electric field, it experiences a force. What happens when conductor is placed in electric field? What we have done, we have put this conductor in electric field, we have put this conductor on in electric field, then it experiences a force. Okay, let us write that force now. What force? That force expression we have already that. Let us write that now. That is F equal to what we get, QE. We know that relation between that force and electric field and charge. So that is from the first chapter, electric charge and fields. That is very simple and you have to write that now. After writing this, we know that what do you mean by Q? Q means the charge flowing in an electron, or flow of electron, you can tell it is. So write it is, instead of Q we can write it as electron, so write it is F equal to minus, it becomes E, that vector you have to write down. This is the, consider this as equation number 1. Okay, after that what we have to take, we know that force formula basically, that is mass into acceleration. Basic formula, it is mass into acceleration. This is second one. So here you have to see that here F equal to minus E into E vector, that after that F equal to M into A. So you have to equate these both. After equating that, we get it is minus E vector equal to M A. So here we are calculating for A, means acceleration. So let us write that A equal to minus E by M. Okay, here we get this. After this we have to take, here you have to see that initial velocity will be 0. Here the initial velocity will be 0. We are finding for final velocity, that we know that basic formula. So first initial velocity I will write that 0. Okay, after that we know that basic formula from the first year science physics, that P equal to U plus AT, that is the formula. So write that now, P equal to U plus AT. Okay, here you have to see what we have to substitute. P means what we can substitute. P means we know that PD means drift velocity. We substitute that drift velocity we are calculating. So let us substitute that drift velocity. After that U, we know that U, that is 0, plus what is A. Here already we have got the A, so substitute that in this. That becomes minus EE divided by M. Okay, in T, how we can write T in that manner? We can write it as tau. Okay, torque means that tau. So it becomes drift velocity equal to 0 neglected, that become minus EE by M into tau. This is the expression we got, and very simple expression. You can easily remember it, and you can easily see here, and you can go on solving this. Very easy derivation. It can be asked in the examinations. Okay friends, thank you.